Hi, I'm David Pockney, and what you're looking at on screen is not a video game. It is, in fact, a piece of music composition software that I've been working on over the last couple of years with Astrid Bin, and it's designed to work alongside a digital audio workstation that you might use, like Ableton or Cubase or Logic and so on. Or you can also use it on its own, and it makes its own sounds. And what I'm going to do today is do a little demonstration of where the software is currently. This is a prototype, it's in a demonstration phase, and a lot of things will probably change as the project gets closer to its conclusion. But I thought I'd do something very simple today and sort of talk through a lot of the features and thinking that's gone into building this software. So I'm going to try and make one of the simplest types of music in this software, and that is a children's nursery rhyme. So I'm going to be spending an almost inordinate amount of time going through in forensic detail how to build the nursery rhyme Frère Jacques from first principles in this software. And the idea behind that is not that this software is designed for children's nursery rhymes or that children's nursery rhymes are the most complex thing you can make in it, but hopefully by choosing some musical material that's very simple, it can help elucidate a bit about the ways in which this program works, and then also hopefully feed some imagination in you as someone watching this about the many possibilities that this tool set can be utilized for. Okay, so what I'm going to do is I have this recording of me making Frère Jacques, and I'm going to be playing back this video and then stopping and explaining stuff, and that's sort of how this is going to go. So one of the first things you're going to notice once the video starts playing is that we have here two screens. And these are essentially two views of the same three-dimensional space. Right, so there are two main components happening in this software. One is this idea of a field or a plateau, seen here in this isometric view. And you're seeing the same field and plateau on this side as well. And then these boxes. And the boxes contain different types of musical material. They could be melody, rhythm, variation, whatever, and you connect them together in this plateau, basically. And underneath here, you'll see that I'm using a game controller to navigate these fields, and the software is built with game controller and controlled by a computer keyboard to be the primary modes of interaction. It's meant to mirror a lot of the ways in which video games function. And so in this demo, what you'll see is that the game controller is in fact split in half. So this half of the game controller controls things on this side of the screen, and this half of the game controller controls things that are happening on this side of the screen. So let's start playing forward and see what happens. Okay, so the first thing we've got is a box, and then on the right here you're able to see exactly what buttons are being pressed. And what we're now going to see over here is we've created a new field. And so this is one of the features of the way in which three-dimensional space is handled in the software, is that you can infinitely nest these fields. So what we've done now is created a field inside a field, and the basic reason for that is so that you can organize your thoughts and your music. You can have some build some little sketch of music in a little field and then connect it up to another field, etc., etc. That's something we'll see as we go further. So we've now zoomed into this field within a field, and we're creating another box. And so this is a menu box where we have a set of possible boxes that we can transform this box into. And for this example, we're going to create a melody. So this will now become a melody box. And here we are. And one of the things you'll see, if I just go back a bit to when we actually create the box, is that when that's done, you'll see that all of these boxes have, they're open boxes. So you have these two back faces visible, and a lot of the ways in which the UI is currently designed is that each box will normally have two faces, normally with different UIs on. And so that is also one of the reasons why you have these two screens. So one reason for having the two screens is that it allows you to do things where you can constantly be comparing the music that you're doing to other music that you've done. So it acts as a way of comparison, so that you constantly have a way of looking back and looking forward to the music that you're making, which I think is the sort of important part of the compositional process. And the second reason is that because you normally have two faces of the box in which have a UI on, you can have essentially like a left face of a box here, right face of a box here, which is something you'll see a bit later. And then often in the center, I'll use this 3D space as a way of creating another type of interface, or a third way of viewing the musical material that's shown on the other two faces. And you'll see that maybe a bit later. So let's go forward. So now we're creating a melody. And this comes to one of the first departures in the way in which music is dealt with within this particular bit of software. So this software is really driven by a thing I call musical representation engine, which is basically the brain of the software that organizes and stores how all of these different musical elements are connected. So in this case, what we're doing here is defining really the starting three notes of Frère Jacques. Do, do, do. So with these three notes, you'll see something slightly different to what you might see in other types of music software. So one is that we're not actually defining any pitches up here, or really any rhythm along here. This is a very relativistic approach to dealing with melody. The only thing we're defining is the set of, we're essentially defining melodic contour. So the thing we're defining is that this note is higher than this note, and this note is higher than that note. And that this note is later than this note, and that this note is later than this note. And so you can see this a bit differently to how lots of different music software deals with the same type of problem. So for instance, if I go into Ableton here, and I wanted to make similarly the first three notes of Frère Jacques, we might do it like this, where we put in do do do. But you see this is a very different approach. So number one, we're dealing with a lot of assumptions that are baked into the software, right? So this is already set as being in 4/4, BPM 120, and then these bars are already, or each beat is already divided into 4. And then as well as that, we're also having to define what the actual notes are, right? So we have C3, D3, and E3. So C, D, and E in the third octave of the piano. And so we're already also tying this to some abstracted idea of an instrument, in this case a piano, although technically these are MIDI numbers and don't actually infer the pitch. But the other important thing is that each of these pitches knows nothing about the other pitches, right? So these are stored in essentially what's a coordinate system, right? You're plotting the position up the y-axis with the position across the x-axis, right? This is similar how if you were like dealing with a map like this, so this is a map of Manchester, you might define Manchester Piccadilly Station as being at H5, right? So you're defining absolute position in space. If you, and this is similar to how things work here, if you go back to the other software that's here, what we're doing is saying that this is a relativistic way of doing things, and so this enables us to encode the contour of a melody without necessarily encoding the details of it. And it also means that each note knows what it's related to, right? All three of these notes are related to each other and are chained together to create a contour. And this becomes a bit more important later when you're dealing with scales, because there are certain scales in which the notes that you play when you're going up the scale are different to the notes that you play when you're going down the scale. An example of this is the melodic minor. So if you don't have a way of encoding the direction of a melody, it makes it very difficult to utilize some of the aspects of that scale, or it makes it difficult to encode that scale into the software. So this is also one of the reasons why this information is stored like this. It means that you always know what note is tuned to what and what direction a melody is moving in. And this type of connection also becomes important if you're doing particular types of tuning where you might be wanting to tune to another note rather than just to a fixed pitch system. But let's move on. So we have our starting three notes. And now what we're going to do is to create a variation box. And here we'll see the basic principles of how you connect together different musical elements in the software. So here if I just move back a bit, so here what's happening is I've created one box here. So we have our original melody box, we have this new variation box, and then what's going to happen is we connect this box to that box, which creates a new box. And so this is based on the types of crafting system that you see in a lot of survival video games like Don't Starve or Minecraft or these types of things, where you'll take two elements, combine them together to create a new element, and then take that new element, combine it with another element to create another new element. So for instance, the idea that you could take lava, combine it with water to create stone, this type of mechanic. And so this is what drives the underlying system of interaction here, right? It's connecting two things together to create a new thing. So if we go forward, you see that happen. It's connected together. We create a new box. And then now we're going to zoom into this other box. And here is where we'll start to see the utility of having two windows. So on this side, I'm now navigating into the same box. And then now we have it set up so we have on this side the left face of the box, and this side the right face of the box. And now this particular box that we've entered is a variation box. So these are essentially two UIs that allow us to create variations. And in this case, the variation of that first box that we created. So then on this side, what we'll see is essentially a tree view of different variations where we can create variations on variations. And then on this side, we have the detail view of whichever part of the tree is selected. So this will become a bit clearer as we move on. So here I'm just selecting the bar, basically, or the notes that I want. So we've now added a new note. So we've taken this starting melody and then we've just added a new note to it. Now, one of the important things to note, no pun intended, about this is that when we're creating variations in here, we're not storing the changed version of the melody, we're storing the changes. And so what I'll do maybe is just let this play out a bit, so there's a couple more examples, and then I'll explain a bit how this variation system works. Okay, so now what we're doing is we've created another variation of this, and then we're going to change this. So if you look here, this is actually the first bar of Frère Jacques, or at least the contour of it, right? We've gone up one pitch, and then down two. And if we imagine that being in a major scale, that's the contour of the thing. And then now we're creating another variation of that initial starting melody, and we can see that over here, right? So this is selected, which means that we can see it over here. And now we're going to see another variation applied to this. So what we're doing, so we have like the original melody transposed upwards, and then this third note lengthened by one, which gives us the do do do. Right, and now we've just created another variation, but in this case a variation of the variation, right? So this is our first variation we've created. We're creating now a variation of that. So if we move forward, and so this is going to be for the do-dee-doo-doo-doo-doo. So firstly, what we're doing is a transposition upwards. Then we're going to end up keeping these two notes, which are essentially these two notes over here, because they don't actually change. And then we'll add in two new notes, and then extend this this selection, so it's longer and encompasses all 6 notes. So the important thing there is that if we just go back a moment, so what you'll see here is that even though in the melody, as you sing it, and if you see this traditionally notated, we know that all 4 of these notes are actually half the length of these 2 notes. Here we're only dealing with contour in its purest sense. So we'll end up applying some rhythmic information to these as we go along the process of creating this nursery rhyme. Right, great. So let's move forward. And then, so let's see, then we're creating a new variation from the original variation, and then this will be our last bar, this do, do, do. And there we go. So then we've created sort of the 4 main bars of Frère Jacques based on variations of this initial 3 notes. And there's some stuff going behind the scenes that makes this possible, makes this maybe a bit more interesting than it might seem on the surface. So one of the first things about this is that, as I mentioned before, we're actually storing the changes to a particular melody when we're creating a variation. We're not necessarily storing the result. And let me just give you some examples of what I mean by that. So this is a book that I've been working on that will be designed to be released alongside the software, probably with a better name. But in here, we can see maybe some examples of how exactly this system works. And I'm using language as an example here because it's more of a familiar territory to people than using pure music is. So this is an example of a set of variations based on a English verb. Right, so we have our starting version of the verb in its ing form. Then we can remove those last three letters to get walk. Then we could add an ed to the end of walk to get walked, add has to the end of walked to get has walked, add will here, and add an s here to get these different verb forms. So you can see this is very similar to the table of variations, or the tree of variations that we have here, right? And so this is very similar to this. Now, there are obviously different ways of storing this information, but one of the ways you can do this is by storing the changes. So if I make this a bit bigger and have these both in the frame, this tree is representing just the changes of this tree, right? So and these are sort of based on what's called the Levenstein distance, which is a way of calculating the distance between two words. But here you can see we have deletion at -1, and -1 means the end of the word. So we're deleting the last letter, then that last letter, then that last letter to get walk. We're inserting E at the end of walk to get walk, and then inserting a D to get walked. And you can see the process. And then for this one, we're just adding an S at the end. Now, what you can see here is that I'm storing the changes that are happening to each variation of this word. And the benefit of that is that you can apply these changes to any regular verb in English. So if we went over to the next page and zoomed in on here, we have that those same set of operators applied to the word sprinting, which gives us then different forms of the verb to sprint, essentially. And so this is what's happening in our when we're dealing with melody here, and also when you see variation happening at any point in this program. We're only storing the changes, which means if you change this original melody, then all of the changes that you made in these boxes will get applied to that initial melody, even if it's different from what you originally started with, which means that then variation can be a thing that can be applied to lots of different material. It becomes a flexible thing. And it also means that what becomes important, all of these different elements, be it a variation or a melody, are all connected to each other and all know their origin and the material that they're operating on, which gives a whole set of different possibilities for music making as we go on. So let's just start moving a bit further forward. So we're now going to make a rhythm. I'm going to use this using a fraction box. And again, we'll split the screen in two. So we're looking at the left face here, right face here. So once again, we're creating a new variation of this starting rhythm. And here again, we're doing something slightly different. When it comes to rhythm, we're trying to get back to first principles, or at least as far back as is practical. So if we go back to like looking at Ableton again, we have a whole load of these different assumptions, right? The idea of a bar, the idea of a 4/4 meter, the idea of a tempo, and the idea of divisions of bars. So these are already a whole set of assumptions that are to do with basically Western European music theory. Here, what I've tried to do is have a much simpler idea of rhythm. I think that things like bars and beats are higher level abstractions of basic rhythmic principles. So the approach that we take is that rhythm is a duration of time either repeated or divided. And we think of it more like a piece of string that is cut or tied together. So for instance, so if we think of time multiplied or time repeated, we might take a length of string and then have another length of string that's the same length, and another length of string that's the same length, and another length of string that's the same length. And there you sort of have your you could say that there's a 4 beats in a bar if you wanted to talk about it in that particular music theory way. And then if you're thinking of time divided, we can imagine, this a piece of string that we then cut in 2, or could cut into 4 sections, and that's time being divided. And down this side, we can see 5 different operators. So we have a way of dividing time, of multiplying time, of stretching time, if you imagine more like a rubber band than a piece of string, adding time, which you can imagine as tying 2 pieces of string together, and then subtracting time, where if we had 2 pieces of string, maybe we just get rid of that one. And so what we'll see here is creating a variation of this starting rhythm, which is essentially just not even amount of time, but it's essentially a fraction. And so what I'm going to do now is multiply it by 4 to get 4 beats in a bar, if we want to go with that sort of abstraction of music. And there you have it, right? Multiply by 4 times to get this 4 beats. And there I've pressed one of the triggers at the back of the controller, which is what causes playback, so I can hear what that sounds like. And then now I'm going to add together or tie together those 2 notes that were at the back to create a new variation that will be used for the second bar of the nursery rhyme. And then here I've divided up those first 2 beats into 4 to get the rhythm of the much faster bar we're looking at. Okay, and then now what we're going to do is use a thing called a container, which is just a way of taking the information that's in one of these trees and then putting it into a linear order. So this is more of like a convenience box, because some of the boxes take information in tree form, some of them take it in an array. And then I'm going to do the same thing over here with the melody, or the variations melodies. So now I'm going to put those into just a linear order. And then what we'll do is combine the 2 boxes together, so these 2 arrays. And the way we'll do this is by firstly creating what's called a combiner box. So we'll take this container and then we'll firstly create this new combiner box here, and then we'll craft together this box and the combiner box to create a new box. And here you can see once we zoom in again, you'll see it. And then now I'm crafting together the container and the combiner box to create a box which contains all of the, once we zoom in, you'll be able to see this properly. So here we can see the array that we just created using the container box. That's the 4 variations of the melody that were in a tree and are now in an array. And then at the bottom we can see the same but for the rhythmic aspects, right? So we have that sort of four or bar containing 4 beats, where and then in this one where we've tied the 2 beats together at the end, and then in this one where the first 2 beats are further subdivided. And then in this UI box, we're going to combine these different things together. So we can take a melody and combine it with one of these rhythms, and we combine it in these boxes in the middle. And then whichever of these boxes is selected, i.e. in yellow, will then appear over here so we can see the result. So let's go forward. So we're going to firstly take this, which is our first bar. We've combined it with the rhythm. And then over here, this is our second bar, again combined with the same rhythm as the first one. So this is, in this melody, is this last note is 2, or has a duration of 2. Then it takes up the span of these 2 beats. Then if we move forward, and here you can see all of these are the same duration until now, when we have that applied from the bottom here. And then now these are the correct length. And then finally, we're going to add this last one. And you'll see at the moment that the do, this is too short. But what we'll do is we'll apply this rhythm to it. And because the last beat is twice as long, this will now become twice as long as well. And there we go. So we now have the sort of starting, or the basic 4 bars of our nursery rhyme, right? Or at least the contours and rhythms of them. So now we're going to use a thing called a structure box, and we're going to combine the structure box to the thing that we just made. And the structure box allows us to order the different things that we've just done. So at the moment we just have one node in our structure, and this is the result. And this is a moment, the number that you see here is the number of the thing that we just made. So in the combiner box, we created these 4 different bars. 0 because it's 0th indexed, which I don't think it'll stay like that because it's a bit confusing. But 0 is the first element in that array. 1 would be the second element, so on and so forth. Hopefully it'll be clear as we start building the structure out. Okay, so we've now copied that, and again the structure uses a tree system, though with more complicated types of music you'll see there's quite a benefit to doing things like this. So again we've now changed this number here, which means we're pulling in the second element of that array, which is that do. And then if we go forward, we create another set of a repeated 2 bars, and then another set of another repeated 2 bars, and there we have used this structure system to build out the resultant sort of contour of our melody for Frère Jacques. And the benefit of having a system like this is that as you can see, these numbers are referencing something else, which is referencing something else, which is referencing something else. And it means that if we wanted to update some of those original variations, these would then automatically update here. We can, do a lot of things, because when we're creating form here, all of these different bars know what their origin is. And so it means when we're creating structure or form in the software, we're not doing it through cut and paste, right? So it's not that if you want to repeat a drum beat, you copy and paste it multiple times. You create one version of the drum beat and then use something like a structure box like this in order to repeat it multiple times. And that also means that at any point you could swap out one of these repetitions for something else, like a variation of that drum beat, which is something you might want to do pretty frequently because, you know, drum fills and all this sort of thing. So, okay, so we now have our basic contour, but, you know, we're not actually even dealing with pitches like C or D or F sharp at the moment. We're dealing with melody in its most abstract form. And so now what we're going to do is we're going to apply a scale to it. So this is a scale box that we've got here. And again, you see we're going to connect these two together to create this sort of melodic contour with a scale applied. And now you'll see me cycling through the different scales on this side and the result happening here. And one of the things you'll notice is that scales here are represented very differently. You know, like pretty much like everything in the software, things are done slightly differently. In most software, the way in which scales are dealt with is by using, thinking of them in terms of set theory. So if we go and find an example within the book, so we want, I think, patterns. Yeah, okay. So if we here are some examples, right? So let's say we have, this is a chromatic scale, right? So 12 notes in an octave like you'd see on a piano. Most programs encode this information like this, right? So each of these is assigned, each pitch is assigned a number going from 0 to 11. And then if you want to create a, let's say a major scale here, you create a subset of this main set. So that means removing some of these values and keeping some of the others. And this works well for most things. Major scale, no problem. But if you start dealing with scales such as the melodic minor scale that I mentioned earlier, where the notes that you use when you're going up the scale are different to notes that you use when you're going down the scale, it means you have to store the scale as a graph rather than a set. And that's essentially what's happening here. Or this is essentially, or even as a group, which is maybe a bit more accurately what this is. So here you can see on the outside the direction when you're going clockwise around the scale, and each of these dots is a pitch essentially. So if we were taking that chromatic example that we were just looking at, you'd have C, C sharp, D, E flat, E, F, etc., etc., etc. And you can see on the outside, that's the way you go when you're going up the scale, and on the inside is how you go when you're going down the scale. And so we're obviously missing out different of these pitches. So if we go back to the melodic minor example, maybe I have to go back. Okay, so if we go back here, you can start to see where the differences might happen. So this half of the scale is pretty much the same, but when we get to here, there's some differences. So from this note, which is the G, so the fifth, if we're going up, we go up 2, up 1. But if we're going down from here, we go down 2, down 2, down 1. So as you can see, there's different notes that are used whether you're going up and down. And if you store your scales as a set, you can't really do this. Or yeah, because you don't have any directional information with the set. Okay, so let's move forward. So now we're at a stage in which we have our scale, we have our melodic contour that's in a structure that has rhythms, that has a scale applied to it. And now we can take the information from this box and make it available to the field that's above it. Right, so that's what just happened now. So this thing means I've just pressed a button that makes this box available from the from this plateau. Right, so I can now connect this box up to there. So at this point we have created our essentially the melodic contour that we need, and now it's time to create the tuning, so the actual sounds that this melodic contour will be interacting with. So now let's define the pitch system, the tuning system, the actual frequencies and ratios that control the melodic contour that we've just defined. And what we're going to aim for here is creating the same type of tuning that you get on a piano, that is 12-tone equal temperament. And we're going to do this one step at a time. And importantly, the idea is not that you'd have to do this every single time that you want to create a melody, but hopefully building this from the ground up will show the flexibility of this system. And you can imagine all the other different types of tuning that you could do using these tools. So let's move forward. So the first thing we're going to do is to create a new subfield here, which we're now going to zoom into. So the first step to this is creating a new box. And this box is going to be of a particular type. It's going to be a generator box, which is a sort of helper box that's similar to the tuning box we'll see later, but works slightly differently. Okay, as we're going through these different options, let me just show you exactly what this is. So the basis behind 12-tone equal temperament, which is the temperament you see on the piano, is that you take a set of frequencies that are in a 3:2 ratio to each other, and you sort of sequentially chain them together to get the base frequencies of the 12 notes in your scale. And as well as thinking that these being in 3:2 ratios, you can also imagine them as being a set of strings, and each string is 2/3 the length of the other. Because when a string is of the same tension and material and thickness, then when you change the length of it by a particular amount, the frequency of that string will change by the amount. So if you half a string, the frequency will be twice as high. If you make a string that is 2/3 the length of another string, the frequency will be in a 3:2 ratio to that bass string. And so that's sort of what you can see here, right? So this is a chain of strings, essentially, or like an abstraction of a string, each of which is 2/3 the length of the previous one. And then on the right hand side, you can see the accumulated values of this. So so each of these blocks is a string, and we're starting off where this is starting in a 1:1 ratio. Essentially, it's just itself. Then we create another string, and that's in a 3:2 ratio. Then we create another string that's in a 3:2 ratio to this one, which gives us 9/4. We create another string that's in a 3:2 ratio, then another one, another one, another one. And you'll notice that these ratios are actually larger than an octave. An octave is normally defined as being a 2:1 ratio. So the highest note is twice the frequency of the lowest note. And what you'll see now is me messing around with some of the tools that can change different aspects of this chain, such as the offset of the chain, whether this is at the bottom or in the center of the chain, and then also its length. But now what we're going to do is we're going to reduce all of these ratios so that they're within a 2:1 ratio, so within the length of an octave as you'd see it on a piano keyboard. So, and we're going to do it as always by combining two boxes together to create a new box, and we can play it back with the default guitar sound that's built in. And now we're going to create another new box. So these are the frequencies that we had before, but they're now reduced into a 2:1 ratio. So their starting their starting value is measured from the center going outwards, and then your reduced value is defined by their radial position around the wheel. So we're going to then create these two together to create so that's a temperament box that we now have on the right here. And this is where things become a bit more complicated, but hopefully this UI is designed in such a way that it becomes a bit easier to explain than it normally would be. Okay, so we have all of these ratios, and what we're now selecting is the target ratio. So the problem we have at the moment is we have 13 notes, and you can see we start here. That is the first note that's in a 3:2. This note is a 3:2 ratio with this one, and then we keep going around in a spiral. But by the time we get to the end, this note is close to this note, but not the same, which means that there's a dissonance between these two notes. And this is just a result of the mathematics. And so the aim in the temperament and the temperament part of 12-tone equal temperament is to make a set of adjustments such that this ending note is the same as the starting note. And so what we're going to be doing now is using this interface to say, okay, the target note, the target ratio we want is here, which will be 1:1, so a ratio of 1:1. And then we're going to select this note and say we want to make it so that this note is this target ratio. So that's what we should see now. So I'm trying out some different ratios here, and then eventually we make it down to 1:1. We're going to switch into another mode, and here we're selecting the distance between this target ratio and the ratio you want to change, and we're then going to split this distance that I've defined into 12, and you'll see that in this top corner. Okay, so now it's into 12, and what we're going to do is to go around and remove 1/12 of this distance off of each of these notes. And because these are all connected together in a chain, it will cause this note to, or this ratio to move to its target. And you see that this in action now. Right, so I'm taking off 1/12 here, 1/12 here, 1/12 here, 1/12 here, 1/12 here, and you can see that it is starting to move around until we get to the end. And then I accidentally make a little mistake here. That should be minus 1/12. Okay, and then I'm going to remove, that cross was indicating that I removed the that final ratio from the collection, because now it's the same as the first one. We don't need it as a duplicate. Okay, so we're going to now create a new box, and in this new box we're going to we're using this, which is a tuning box, and we're going to use this for creating some other octaves. And this tuning box is actually a simplified version of the generator box we saw at the beginning of this, where we had that chain of just fifths. And this box we're going to use to basically create other octaves out of the 12 notes that we've just created. So you can see we've just created a string that's half the frequency of the original one, which means that it's twice the length, and another string that is half the length, which means it's twice the frequency. So twice the length, half the frequency, half the length, twice the frequency. And you can see here on this other wall, briefly, this is another view of the same information, here with the pitches arranged from lowest to highest along the x-axis here. So, yeah, and there you can see that. So we're going to now combine these two together, and actually here you can see quite nicely the crafting approach, right? So we take this box, create a new box, this box with that new box to create a new box, this box with that box to create a new box. This is the sort of basis of that system. So now what we've done is created a set of 3 octaves. So we have our starting 12 notes, which we created through the temperament system. Then we have 1 octave that is lower, which means that so this is that octave, and this is that octave. And these octaves are created by essentially multiplying the starting octave by each of these values. So now we have a 3 octave set of ratios. And here I'm playing back the So there we go. So let's say, so we now have 3 octaves of 12 tone equal temperament. So this would be equivalent of having 3 octaves that you have on the piano. And again, what I've done, let me just go back a moment. So now what I've done is similar to what I was doing with the melody, is we're switching into this sort of connection view right now, or in a moment. Yeah, here we are. And yeah, so here again, I've selected this so that it becomes the output for this field. And so it now can be, this box can now be accessed from the top level field, which we'll see in a moment. So we have a melodic contour over here. We have a tuning system over here. And now what we're going to do is combine them together to create essentially a melodic system, or we're going to create a melodic contour with a particular tuning system. So yeah, now these are accessible. We can connect them together to create a new box in the center. And this, we can see that original starting melody or melodic contour for Frère Jacques, and that now has the tuning information in it. But in order to be able to hear it back, we're going to create a guitar string and connect it to that. So now these set of ratios, this tuning system, will be played back on this guitar string, and this should be Frère Jacques. And so there we have it. We have Frère Jacques built from first principles in this software. And so you can see this software has a lot of depth to it. And you can see that even though throughout this we're using very simple musical material, hopefully it's clear that there's a flexibility both in the internal musical representation engine, and also an amount of flexibility that's in the elements of the UI that would allow a whole set of much more complex and much more sophisticated types of music to occur in here. So hopefully this has made you a bit interested and excited in this project, and please follow along or send me any emails if you want to know any more information about it. Okay, thanks.